Okay, our last example here is a piecewise graph, and we did these back in GeoTrig. That was the first place you got introduced to these. Basically, there are two different equations on the same piece of graph paper for different domains. Okay, so that's all a piecewise function is or ever will be. The function itself here is very basic. 3x is a line, and x minus 2 is a line. So they're just two lines. Okay. But the 3x line only lives from 0 to 2, and the x minus 2 line only lives from 2 to 4, not including 2, not including 4. All right, so again, consider open circle scenarios here when you're graphing. So I'm going to do the 3x in blue and the x minus 2 in green, just to keep with the highlights. So I got xy, and I got xy. To do a piecewise graph, you simply make a different XY chart for each part of the graph. Graph each part of the graph on its domain only, okay, and that's it. So basically, that's two different problems, just like these last two problems were all by themselves. The first problem was graph this only on this domain. Second problem was graph this only on this domain. This is just two of those problems in the same problem. All right, so if I start with this one, I want to pick values between 0 and 2, but not including 2. Okay, so I'm going to pick 0, 1, and 2. Okay, and I just said the words, they just came out of my mouth, not including 2, but I put 2 anyway, because when you graph piecewise functions, be a little bit rebellious. Even though you're not allowed to pick it anyway. But know that if it does say equals 2, you're going to get a closed circle. If it says less than, not equal to, you're going to get an open circle. Okay, figure out where the graph would be at that point, but then put an open circle to say that point doesn't really exist. All right, that's how you handle that. And all I got to do to find y for the blue graph is multiply by 3. 0 times 3 is 0. 1 times 3 is 3. 2 times 3 is 6. Just like that, I get some points. 3 points is plenty to graph a line, so I'm not going to go beyond that. I'm going to wait to put points on here before I decide a scale. All right, I want to find out what the x points or the green points look like before I pick a scale. If I'm graphing x minus 2 from 2 to 4, I only want to pick numbers between 2 and 4, but not including 4, so I'm going to pick 2, 3, and 4. Again, I'm going to be rebellious, even though I'm not allowed to pick 4, I'm picking it anyway. You can't stop me. All right. So, equals 2 means we're allowed to, so I'm going to put a closed circle. So the point I get there is going to exist. I'm going to put a closed circle to represent it. The point I get at 4, though, is not allowed to be there, so I'm going to put an open circle. So I'm going to find out what it should be, but I'm going to put an open circle and say, even though this is what it should be, it doesn't exist, so I'm going to put an open circle to represent that. All right. The values on this graph are determined by subtracting 2 from x. 2 minus 2 is 0, 3 minus 2 is 1, 4 minus 2 is 2. So looking at the x's, I'm going all the way from 0 up to 4. I've got a lot of space here, so I'm going to go to 0.5 scale on the x-axis. I've got to go up to 6 on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Can't quite make it, so I'm going to go y to 1 scale. And again, a 1 scale is what it typically is. But if I'm going to scale anything, I'm going to make sure everything's scaled so, again, the person reading your graph knows what you're talking about. All right? Am I supposed to assume it's a 1, or am I supposed to assume it's the same? I don't know. So you tell me exactly what it is so I know how to read it. So if I'm graphing the blue points, 0, 0 is right here. I'm going to 0.5 scale, 0.51 over, and then 3 up. Again, y is going to 1 scale. Then I got to go 1.52, 1, 2, 3, 4, 5, 6 up, and I'm going to put an open circle there. There are no arrows when there's a domain that's an interval. So we're going from 0 up to 2. We're going to connect those dots with a straight line starting here, ending there, with no arrows on it. The beginning is a closed circle endpoint. The end is an open circle endpoint. Then we graph the green points the same manner. So 2, 0 is right here, just below 2, 6. And then 2.53, we're going up 1. 3.54, we're going up 2 with an open circle on that one. Again, only place open circles are ever going to happen is at the end points. So every point in between is always a closed circle. The endpoints themselves can be either closed if it's equal to or open if it's not. And again, I'm simply connecting those dots with a straight line also. No arrows on the line because, again, we have a beginning and ending point. So looking at this graph, again, I'm looking for absolute minimums, absolute maximums, local minimums, local maximums. All right. Looking at this graph, I can see that the absolutely lowest point it hits is here at 0. Happens twice, right? So just like the last graph, absolute minimum of 0 at x equals 0 and again at 2. The absolute maximum value would occur here, but it doesn't exist. And the local maximum value would happen here, but it doesn't exist. So there is no absolute maximum, there is no local maximum, or even local minimum. There's only absolute minimums in this graph. So again, in the case of the open circles, this is where it would be, but it doesn't exist, it doesn't count. So don't even mention it. If you wanted to go to this extent of saying there is no absolute maximum, you can do that if you want to. You not writing it on your paper makes me assume you think there isn't one. So you're welcome to leave it just blank like that too.